Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Faridina binti Muhammad Khairul Faisal. This is my team's member, Afiq bin Khairul Nizam, Amar Hazib bin Muhammad Sanusi, and Nur Syafiqah binti Maknawi. We from Fantastic 4 need to discuss about Stokes Theorem. The introduction of Stokes Theorem state that the surface integral of the curve of a function over a surface bounded by a closed surface is equal to the line integral of the particular vector function around the surface. Stokes theorem provides a relationship between line integral and surface integral. Based on our convenience, one can compute one integral in terms of the others. Stokes theorem is also used in evaluating the curve of a vector field. Stokes theorem and the generalized form of this theorem are fundamental in determining the line integral of some particular curve and evaluating a bounded surface curve. The surface integral of del Fn over each of surface which has the same boundary C are the same. We have two questions about Stokes theorem application. The question number 1 is, by using Stokes theorem, evaluate surface integral double integral curve f ds for the vector f is equal to negative yi plus xj plus zk, and S is sphere of x square plus y square plus z square is equal to 13.2. Inside the cylinder, x square plus y square is equal to 16. In the counterclockwise direction, when viewed from the position z exists. From this Stokes theorem, we have two methods. So, I will be discuss about method 1. So before we want to find the differentiation about method 1, we need to find the line integral. So the first step is we need to find z, x and y. For value of z is equal to 4, x is equal to r cos t and y is equal to r sin t. After that, we need to find the r dot dr. So the value of f is we need to use the function negative yi, xj, and zk. We simplify the value into the x, y, and z. The value of f dot dr is equal to negative 4 sin t, 4 cos t, and 4. After that, we need to find the rt. The value of rt is 4 cos t, 4 sin t, and 4. And then, the value of r prime t is negative 4 sin t, 4 cos t, and 0. After we find the f dot dr, rt, and r prime t, we need to find the integration of f dot dr equal to integration of f dot r prime t. The value of f dot r prime t is negative 4 sin t, 4 cos t, and 4. And then multiply by negative 4 sin t, 4 cos t, and 0. The answer is 16 sin square t plus 16 cos square t. After that, we need to simplify 16 sin square t plus 16 cos square t. The answer is 16. And then we need to differentiation using the integration f dot dr. And then the limit of circle is 0 to 2 pi. And the last answer, I will continue explain about question 1 using method 2. First of all, we will find the del f using metric method. We find the value of ijk. So at the end, we got 0, 0, 2. And then we find the value of del f dot del g, so we get 2. Then use the double integral. First limit 0 to 2 pi and second limit 0 to 4 to r dr d theta. Substitute all the value of the limit, and then at the end we get the answer is 32 pi.
So my name is Afiq. So the next question is about application of Stokes theorem in life. So, considering a cylindrical wire of radius equal to 2 and with a given velocity field v equal to x squared plus y squared I plus y squared negative x squared j flowing through it. Applying Stokes' theorem, calculate the circulation of the velocity field around the wire and explain how this calculation could be relevant in the design of pipelines of fluid flow system. Okay, the calculation will be made by Amar, and I will explain how this calculation could be relevant in the design of pipelines or fluid flow systems. So when a fluid flows through a cylindrical wire, there are physical principles that describe the behavior of the flow. Stokes' theorem is a mathematical concept that can be applied to calculate the circulation of the velocity field. The calculation is relevant in the design pipelines and fluid flow system because it helps to engineers and researchers behave within the system. By analyzing the circulation of the velocity field, engineers and researchers can gain knowledge and more characteristic of fluid flow, enabling them to optimize the design and operation of pipelines and fluid system of variation application. Thank you.
So we proceed to question 2, that is application. So for this question, we consider a cylindrical wire of radius r is 2 cm with a given velocity v equal to x squared plus y squared I plus y squared minus x squared j flow through it. Apply a Stokes theorem, calculate the circulation of a velocity field around the wire and explain how this calculation could be relevant in the design of pipelines or fluid flow system. So at this question, this question want a line integral. So we are use surface integral to solve this question. So for this question, we know the formula of surface integral, that is a v dot by dr. So we want to search the v. We know v magnitude of v equal to magnitude of v equal to x square plus y square for x component, and y component is y square minus x square. So for the dr is the same with r prime, that is a delta x and delta y. So we solve this equation. The final answer for this question is 2x plus 2y. So the final, we integrate this answer and get the answer is 0.